So today we're going to be looking at quadratics, and we're going to be kind of looking at the solutions of quadratics, or one of the ways we can solve for quadratics. So when we're looking at quadratics, the solutions to a quadratic equation are the points at which the function intersects the x-axis. Okay. So that's our first blank. The solutions are also referred to as our zeros, our roots, and or our x-intercepts. So these three words are interchangeable: zeros, roots, x-intercepts. You might see them switched out throughout. Again, they all refer to the same thing, where your graph or your function crosses that x-axis.
Intercept is when it crosses the x-axis, right? X-intercept the y-intercept where it crosses.
Yes. So when we're talking about quadratics, we have three possible outcomes. We can have two solutions, one solution, or no real solutions. So in this case, if we were to look at them graphically, we can have two solutions if it's a positive quadratic and our vertex is below the x-axis, so we cross the x-axis twice.
Wait, is this going in two solution box?
This goes in two solution box. Yeah. Or if it's a negative leading coefficient quadratic and our vertex is above the x-axis. Because again, both of these have two x-intercepts or two zeros.
Do we write both of those on this one?
You can. So again, this has a positive coefficient, leading coefficient. This one has a negative leading coefficient. And then we have one solution if our vertex lands on the x-axis. So it can be positive or negative as long as it lands on that x-axis itself. And then we could have the same thing of no real solutions if we have a positive quadratic and it's above the x-axis, or a negative quadratic and it's below the x-axis.
If it's on the one that's below the x-axis, is it still negative or positive? No,
Yes.
On the one solution.
On the one solution, yeah. So this would be a leading coefficient or a positive a value. But we're talking about our standard a x squared plus bx plus c. So these are our positive a values.
Well, I thought you said that one was positive or negative on the second one.
And then this one's negative a value.
No, the other one.
This one?
The one solution.
Yeah, so again, we can have a positive a value or a negative a value where we have one solution where the vertex lands on the x-axis.
Okay, because I wrote positive or negative on the top one on one solution.
So yeah, the positive and the negative just tells you which direction the quadratic opens.
Okay.
Whether it opens up or if it opens down.
So we should automatically know we should automatically know like what solution is linked based on where the slope is.
Kind of where the vertex is, and then whether we open up or down.
Okay.
Because if we open up and we're below the x-axis, we know we're going to cross it too. We're going to have 2 points, right? If we open up and we have our vertex on the x-axis, again, you're going to have the 1. Or if you open up and you're above the x-axis, you're going to have 0. Okay, so that's how we're going to determine the amount of solutions that we have. So let's look at number 1. And again, we're just going to find how many solutions are possible. We don't have to find those exact solutions. So number 1, we have f of x equals x squared plus 2x minus 3. So if we want to find our vertex, the way we're going to do that is we're going to use this little bit of formula, negative b over 2a. Okay. Some of you might recognize this. This is the start of your quadratic formula. So we're going to take the negative of our b value, which again our b value is attached to our x. So negative 2 divided by 2 times our a value, or our leading coefficient, which in this case would be a 1. And that's going to give us our x value for our vertex. So in this case, negative times 2 gets you negative 2. 2 times 1 gets you 2. And we simplify that, negative 2 divided by 2 gives you a value of 1. So this is our x value of our vertex.
So a negative divided by positive equals a positive.
Nope, it equals a negative. That was my bad. Thank you, sir. So then, if we have our x value of our vertex, to find our y value, so to find how far it shifts up or down, we're going to take that x value, we're going to plug it into our function to find our y. Because again, f of x is our y value. So we have y equals, and I'm going to plug in negative 1 for my x. So I have negative 1 squared plus 2 times negative 1 minus 3. And again, all I've done is taken my value that I solved for and replaced my x's with those values. So if I have negative 1 squared,
That's 1.
gives me 1. 2 times negative 1,
Negative 2.
negative 2, and then a minus 3. Combine all of our like terms, so we have 1 minus 2,
That's
negative 1,
Never mind.
minus a 3, negative 4. So our vertex is going to be at the point negative 1, negative 4.
So we first solve for, I guess, solve for the x vertex.
Mhm.
We take our solution and then we solve for
The y.
Okay, cool.
Okay, so now we have kind of the starting point of our quadratics. So we have our vertex. Now, based on our a value, we can determine how many solutions we're going to have. So in this case, our a value is positive, and our y value is at negative 4, meaning we're below our x-axis. So if our a value is positive and our vertex is below the x-axis, how many solutions are we going to have? 2. So we have 2 solutions.
Do we write that on like the solution, so I'm like graphing?
So yeah, number 1, we have 2 solutions.
Do we just write the number 2 or do we write out solutions?
You can put 2 or 2 solutions, whichever you prefer. Okay. So then let's look at number 2. Number 2, f of x equals negative x squared minus 10x minus 25. So again, first thing, we need to find our x value for our vertex. So negative b over 2a. And our a value this time is a negative 1. So negative b over 2a. So negative times a negative gets us a positive 10. And 2 times negative 1 gets us a negative 2. And then 10 times divided by negative 2 is negative 5. So there's our x value for our vertex. Now we need to find our y value. So we're going to take that, plug it right back in for our x value. So we have negative times negative 5 squared minus 10 times negative 5 minus 25. So we need to simplify. Negative 5 squared is going to give us 25. We also have that negative out front, so it's actually going to stay negative. Negative 10 times negative 5 becomes a positive 50, and then minus our 25. So y equals 0. So that means our vertex is going to be at negative 5, 0. So if we are to graph that, we're at negative 5, we're at 0,
So that'd be one solution.
it's going to be one solution, and we're going to open down in this case because our A value is negative.
Did we graph the first one?
No, I forgot to do that. I just used that example that I already had up there. So we're at negative 1, negative 4, and we have that positive A value. So that would be a sketch of our graph for that first one.
But what's 2? Is it?
One solution.
2 is a one solution.
Because again, our vertex is on that x-axis, so we just touch it there. Okay. So let's go ahead and do number 3. So we have f of x equals x squared minus 6x plus 8. So again, what equation are we going to use to find our x?
Negative b over 2a.
Negative b over 2a. So we have negative times negative 6.
That's going to be 6 over 2 times 1, which is 6 over 2, and that's going to equal 3.
Very good.
And then you gotta plug it back into problem, so it'll be 30 squared minus 6 times 3 plus 8, and then 3 squared is 9, and then negative 6 times 3 is negative 18. Then you're gonna add the 8, and then that's gonna equal
9 plus 8
is 17.
is minus 18.
It's negative 1,
We get negative 1.
and then
So our vertex is at 3, negative 1.
Oh my gosh.
She's got it. 1, 2, 3, down 1. So there's our vertex. Do we open up or open down?
Can you give me a little bit to write it down?
We open down.
What's our A value?
oh, it's positive, so
It's positive, so we're going to open up on this one.
so it's just one solution.
How many times do we cross the x-axis?
2.
Twice, so it's
Twice.
2 solutions.
So we have 2 solutions.
Oh my goodness, okay, so help me.
You can only math you like I actually understand your math.
Okay, so I'm gonna try to decode what just happened.
Mm-hmm.
Since I'm gonna decode what just happened.
So we
So-
got our solution, negative b over 2a. Okay, so
So we took our b, negative 6, multiplied by our negative, so that gives us our 6. 2 times our A was 1, so that just gave us a 2. So we got 3. We take that 3 and we replace our x's in the equation with that 3.
right.
So that gives us this. Then we just started simplifying as much as we can. 3 squared gets you 9. 6 times 3 gets you that negative 18. And then combine our terms, we get that negative 1. So our vertex was at 3, negative 1.
When you want the answer.
And then we graphed
I'm
from
gonna
there.
do that.
There's a lot. There's a lot
I'm
coming
gonna
quick.
do
Yes.
How do you tell if your arrow is going up or down?
We tell that based off of our A value. Okay, so based off of that, if A is positive,
Then it will open up.
then it goes up. If A is negative, we go down.
And that's what we're
You want to solve it?
So that's how we can determine how many solutions are going to be on our quadratics. Okay. Again, based off of where our vertex is, and then based off if our A is positive or negative. Okay. So what is the point of that? Well, what we're looking for is to find our solutions to the quadratics And we've kind of been working with one of the methods to find our solutions, and that is factoring. So we're going to solve these quadratics by factoring. Now that we kind of have an idea of how they work graphically, we're just going to solve them with our factoring. So the way we factor or solve by factoring is kind of got 4 steps that we want to follow every time. First step is move all the terms to one side or set of the equation and set it equal to 0. Second step would be factor it. Our third step, and here's what we haven't been doing, is set each of those factors equal to 0 and solve for each x value. And then our fourth one is write your answer as a solution set. So notice we have these little squiggly brackets and not just our parentheses. Because again, parentheses denote that we're talking about a point, where those little squiggly or curly brackets denote that we're talking about a set. So that's what's new with that. So let's look at number 1. We've got x squared plus 9x equals 0. So again,
Can you find out what goes into 9x?
so yeah, we want to factor this as much as possible. And we only have 2 terms, so that's a hint that we only have really 2 methods that we could do, and that would be our perfect squares or our GCF. So which of those would we use? GCF, right? What can we take out that these both have in common? An x. So I want to factor out of x. I'm dividing both by x, so x squared divided by x leaves me with x plus 9x divided by x. Gives me 9. So we factored it. Now we're on to our third step. Set each factor equal to 0 and solve. So I'm going to take both factors and set them equal to 0. So x equals 0. That one's already solved for. We have x plus 9 equals 0. And we want to solve for that x. So to solve for that x, we need to move our 9 to the other side. So subtract 9 from both sides. And that gets us not 0.
So would it be 0, -9 is the answer?
So our set, or what x is equal to, our x-intercepts, our zeros, our roots, all those the same, are 0, -9. Again, we can use those little curly brackets.
Let me write that down. X equals 0, 9. Okay.
So those are our solutions to this quadratic, right? If I plug in 0, 0 squared is 0, plus 9 times 0 is 0. So 0 equals 0 is true. And -9 squared gets you 81, plus a 9 times a -9, which gets you -81. So 81 minus 81 gets you 0.
Can I write the squiggly brackets like this?
You can't see it from here. But yeah, as long as it's,
I write mine like this.
that's fine, yeah. As long as it doesn't look too much like a 3.
So we
It
have
looks like a
to,
backwards 3 kind of.
Okay.
so we have to factor like every single time.
So yeah, these are solving by factoring.
So the first, I guess, like the first placement was always going to be 0.
Not always. It was because this factor was just x. So let's look at number 3. So we have x squared minus 4 equals 0. So in this case, what factoring method should we use?
Division? Or GCS?
Square root, right? So this one was GCF because they both had a like term.
Oh, okay.
This one's going to be our square root because these are
So
both
if it only has one like term, it's square
perfect
root?
squares. Yeah. We do have to factor it. So we're going to factor by perfect squares.
Yes.
Again, whenever we do that, got that positive, negative. We can take the square root of the first term. Square root of x squared gives me an x. Take the square root of your second term. We get 2. 0. And then we set our factors equal to 0. So we have x plus 2 equals 0. And x minus 2 equals 0. So then we solve for x. So subtract 2 over, we're going to get x equals -2. And for this one, we're going to add 2 over. So x is going to also equal +2.
So, how do we get to, we did square root of 2 squared, or x squared?
So this was the difference of perfect squares. So we can take the square root of each and turn it into a factors, right? If we FOIL this back out, x times x gets us that x squared. Then we're going to get a -2x and a +2x. And those cancel. And then 2 times -2 gets us that -4.
Okay.
So that's that
say
difference of
for-
perfect squares.
What about problems like numbers, I guess 6?
So let's do that. What was your question, Grayson?
Can I go to the restroom?
Yes. So let's look at number 6.
Number 6.
Yes.
So we have 2x squared minus 2x.
Can you factor out 2?
We can factor out the 2. So first thing is GCF in this case. All of those have a 2 in common. So we'll take our 2 out to the side, rewrite our equation.
So it'll be x squared minus x minus 12
Equals 0. And then we're going to take this, our new trinomial, and factor that. So our 2 just going to stay out front. So what is x squared minus x minus 12 factor into? What are our signs going to be?
Wait, am I wrong?
Plus and minus. Not going to square root it. That would be our perfect squares. So this is just our trinomial. So we need
4 and 3. Positive.
So yeah, we need 2 numbers that multiply to get 12, whose difference is a -1.
So before
Positive 4, negative 3.
So
no.
Negative.
negative 4, positive 3, right? 3 minus 4 gets us that -4. Okay. So now we're going to set our factors equal to 0. This 2 that we took out doesn't have an x with it, so we're really just going to kind of ignore it. Because there's no variable with it, 2 cannot equal 0,
When you do 2 times x,
so we're just going to ignore it. No, we're not going to do the 2 times x. We're not going to multiply it in, because then we would just end up dividing by it, and we'd end up with the same result as this.
okay.
So then we're going to take both of these, again, set them equal to 0, and solve. And what do we notice every time we set just a binomial with no number in front of our x? What does it result in? So if we have x plus 3, we solve for x
And that's -3 and then +4.
and a +4. So what's kind of a little shortcut that we can do?
The opposite of the number.
The opposite of that number, right? Whenever you take that binomial and set it equal to 0, we're just changing the sign by moving it over, right?
Interesting.
So we can kind of skip this step once you recognize that.
I thought so. I didn't know.
So again, that's our normal trinomial method. Let's look at the other method that we did on Monday, which is our slide and divide method.
Which problem are we doing?
We're doing number 7. We have 3x squared minus 13x minus 30 equals 0
You want to take the 3 and multiply it with 0 or 30?
by the 30. So we're going to take our 3 and slide and multiply by the 30
That's x squared.
squared
Equals equals 90, I mean minus 90
minus that.
equals 0.
Is that x by the power of 2?
Yes. And then we need to factor that. So again, x and x. What are our signs going to be?
Positive, negative.
Positive, negative, plus, minus. So we need two numbers that multiply to get 90 whose difference is 13. If you don't know those off the top of your head, the factors of 90, again, we can always use that calculator. Go to our y equals, in this case, I want to put in 90 divided by x. Then we want to go to our table. So y equals 90 divided by x, second table. And that's going to give us our factors of 90. And we want to find the difference of 13. So as we're looking through, we need two numbers, 5 and 18. We need that negative 13. That means we need a positive 5 minus 18. So there's our factors. So then what does x equal?
5.
Negative 5, positive 18.
Negative 5 and a positive 18.
Wait, how is that a negative 5 is a positive sign?
Because when we set it equal to 0, remember we're going to have to subtract it over.
Oh, I thought, okay, I was thinking of something else.
And so we change our signs of those two factors, and there's our set. So x equals negative 5 and 18. And again, these are our x-intercepts that we just solved for.
Okay. So where do we get, I'm sorry, where do we get like 5 and 18 from?
So 5 and 18. So whenever we were factoring this, right, we're looking for a product of 90. So two numbers that multiply to get 90. And then whose sum gives us that 13. Or whose difference gives us that 13. Because to get a negative product, we have to have a positive times a negative, right? And so when we do 5 times 18, that gets us this 90. And then 5 minus 18 gets us that negative 13.
Now, I'm guessing our homework is not this.
No, this is still just notes on this page.
So
So on the next page, now they're not in standard form.
How many copies? Oh.
So we can do any of these that you want me to. Or
Number 14.
number 14. Let's look at what we can do both. Number 14, we've got x squared.
Plus 11x plus 29 equals x plus 4. Will we do the slide and divide? Wait, no.
I don't know yet. We're gonna have to find out.
oh wow.
So in this case, first we need to move our x and our 4. We want to get it all onto one side of the equation, right? And another thing that we want to do is we want to make sure that our x squared has a positive leading coefficient. We don't want to have to deal with negatives over here. So generally, whatever side you're going to have your big x squared on is the side you want to move everything to. So in this case, I need to move my x and my 4 over. So I'm going to subtract x and subtract 4. So then I'm going to rewrite it, x squared
Plus 10
plus 10x
equals
Wait,
25.
hold on. What was the
Plus
first?
25
plus 25
My bad.
equals 0.
equals 0, right? So you cancel those out.
Wait, so it's x squared plus 10.
It's 11x.
So everything that's on the left side, but on the right side of the equal sign, have to factor in over onto the.
Yeah, we want to get it set
Oh, no, no.
equal to 0.
Okay.
So then, once we have it, everything on the one side of the equation, now we can factor it. So in this case, we have a leading coefficient of 1, so that's just our normal trinomial factoring. So what are my signs going to be?
Plus, and it's 5 and 5.
Plus, plus, and it is 5 times 5 gets us 25, and 5 plus 5 gets us that 10. So then x equals
-5, -5.
negative 5, or we can just say negative 5.
Why does x equal negative 5?
Because when you set it equal to 0, we have to subtract the 5.
Yep.
So it makes it negative.
So we set both of these factors equal to 0.
So
and then
they're-
solve.
not need the squiggly things?
No, because it's just a single
It's
term.
the same.
So if they're both the same thing, it's only one.
You only have to put it once. You can put it twice.
Well,
So that would be what we call a multiplicity. We have a multiplicity at -5, and that means, again, we only have that one solution with that quadratic. And that means we're actually touching that x-axis at -5 and we're bouncing off. Okay, so that's what that would be. We have that point,
so it'd be one solution.
so we have that one solution at that -5.
Nice.
What was the other number that you wanted to do?
6, 15.
15?
Yeah.
So let's look at 15.
2x squared minus 9x minus 65 equals x squared minus x.
Okay.
So we subtract them from that side, move to that side.
Yeah, so we want to move these over to this side, so we're going to subtract x squared.
And we subtract from the never mind.
And then, well, from like terms, right? So x squareds with x squareds. Then we'll add that x over
Because it's already negative.
because it's already negative. So,
Wouldn't that x squared be marked out?
so yeah, we're going to mark those out. Those cancel each other out.
So it'd be 2 minus 9x, or 10x.
8x.
Be 2x.
So that's going to give us a
Wait,
negative
minus
8x.
2.
Yep, 2x squared minus an x squared leaves us with just an x squared minus 65. Everything on that side is gone, so we just have that 0. So then we need to factor this.
It'd be like the other 2 parentheses.
What are our signs going to be?
Negative.
Plus,
Plus minus.
Plus, minus, negative, plus, either way. So we need 2 numbers that multiply to get 65, whose difference is 8. And again, if you don't know that off the top of your head, you can go to that y equals 65 divided by x, second table, 13 and 5. And we need a -8, so our bigger number needs to be the negative. So we have x plus 5, x minus 13. Set those equal to 0 and solve, so x is going to equal -5 and positive 13.
why did the 9x go to an 8x?
Because we added an x to it. Right, we had that negative x on this side, so we added 1 over
Okay.
to get it set equal to 0. Okay. So that is our solving quadratics by factoring. Yes.
Can I have the paper?
Okay.